Hello, I'm Miss Myers. Welcome to the Sound of Science. Um, if you happen to have stumbled across this channel because you're super interested in science and how, in particular, biology works, um, welcome. You're certainly welcome to be here. If you are here because more likely you're my student and I've directed you to this channel so that you can complete your coursework for me this year, you're welcome too. And I understand that this is probably not what you were expecting. Um, but regardless, welcome anyway. Today, our very first lecture, I'm going to be starting off with the most basic aspects of science, the very nature of science. And to help you understand the difference between science and pseudoscience, I am going to explain what science is used for, how science is completed, and help you understand what really makes science actually science. So, to begin, I want you to know that science is just a systematic way to study the natural world. Um, we're born scientists. We actually do science as babies. And really, the only difference between a toddler and a scientist is how systematic and organized they are. Um, for example, the picture kind of behind me that you can sort of see is a shape sorter. This shape sorter is designed so that babies can take the shapes and try to fit them in the different shaped holes, right? Babies actually use an entire method to figure out how all of this works. We recognize as infants that we want the blocks to go into the sorter. And so we research. And babies research the way babies research. They chew on the blocks, they drool on them, they observe them, they throw them, they hold them, and then they decide that they're going to try to push the blocks through any way that they can. Um, they do this experimentally, sort of. Then they collect data on their attempt, and when it doesn't work, they revise it and they try again. All of this is science. And what's more, all of this is how our brains work to help us understand the world around us. So you are a scientist. You always have been. If you're thinking right now how hard science is and how you don't do well in science, then consider that you've bought into the lie that science is hard. It's not. Your brain is literally designed to do this. But somewhere along the way, someone told you that science is really difficult and you have to work very, very hard. And in some ways you do. There's a lot of knowledge you need to know, and there's a lot of information you need to take in and understand. But that doesn't mean that you aren't naturally born to do science. Everyone is. And if you're sitting there again thinking, I'm not a science person, I'm hoping that by the end of our course that you understand that you are. You are all science people. You literally were made this way. So, having said that, a few things to remember since you're a scientist is that science is testable and it's observable. We use a method to understand our world. We call it the scientific method. And sometimes we're able to experiment to gain knowledge in a lab. Sometimes our knowledge is based on observations. Um, think of it this way. If you have conditions that you want to test, like let's say that you want to test or experiment with tornadoes, you're not going to bring a tornado into the lab. Or you want to work with African elephants. They are notoriously difficult to move into a lab setting. So, in order to study them, you're going to have to study really from a distance using observations. That doesn't make it any less scientific. It just means you have to work really hard to control your variables. Science also has to be reproducible. If it only happens one time, that's not science. Science has to be organized and systematic. If you are not a naturally organized person, welcome to the club. Neither am I, and it's going to be okay. We'll get through that. We use this basic method though to make certain that we're studying the world in a way that we're getting accurate information, and that's what we mean by organized, and that's what we mean by systematic. Science is also always being updated. As we learn more information, we update our theories and we increase our knowledge. Okay, another note. So many people viewing this video will believe that theories are what we think, but laws are true. This is a severe misunderstanding. We start with a hypothesis, and a hypothesis is a prediction. It's what we think will happen, but it's not just a prediction that we just make out of nowhere. We base it on observations and on previous knowledge and things that we've already learned. So this prediction is what we think will happen, but it's educated. It's based on what we already know. Theories, then, are explanations for why something happens. It's the phenomenon we're trying to understand. A theory explains it, and it's true. They're accurate to the best of our knowledge. If later we find more information, maybe that contradicts it or adds to it, we'll update the theory to include that information. It doesn't mean that a scientific theory is just a guess, though. Very far from it. A scientific theory is very well supported, and it's a well tested concept. It explains a natural phenomenon. And I keep using that word explain. That's because the difference between a theory and a law is that a theory explains a well tested concept or a phenomenon. Laws are a statement describing what happens under certain conditions. It's a statement of fact. It doesn't seek to explain why something happens or even how in most cases. Usually, a law is going to be a short statement or a mathematical formula. It is not going to explain why it happens the way that it does. Okay, so now that we've got that straight, just remember theories are true, so are laws. Hypotheses are these guesses that, not even a guess, these are predictions that are based on the observations that we've seen. Okay, so let's take a look at the difference between observation and inference. Observations are things that we can discern with our senses, what we can see, smell, hear, touch, taste. From these observations, we can create inferences. These are logical interpretations based on what we've experienced. I used to do this quick demonstration with my classes, and I would pop out of my prep room, which is usually the room hidden in the back that says no students here. And I would hold up something that looked similar to what's sitting on the table in this picture. And I would light it. And after about 30 seconds or so, I would ask my students what they observed. And they would always give me plenty of inferences mixed in with actual observations. Those inferences were pretty easy to identify because as soon as they got more information, like when I took a bite out of the candle, then those inferences turned out to be untrue. So be careful you don't fall into the same trap. And for those of you that are curious, the candle in this picture is actually string cheese with a little slither of almond stuck in the top that, because of the almond oil, will actually light and will stay lit for about 25-30 seconds. Okay, so some people make claims that they say are based on scientific evidence, but it's not. And the question is, how can you tell the difference? What is the difference between science and pseudoscience? Well, it's pretty easy to identify pseudoscience because it's going to have unchanging fixed ideas. No matter what studies come out, pseudoscience remains fixed. It's not going to update its theory. It's not going to change. It's not going to allow for new information. They're not going to have any peer review in journals. And typically, this is often explained away as saying there's some type of conspiracy. Somebody doesn't want you to know this information. And in fact, if a professional criticizes the claim or questions the claim, then that person is obviously just trying to prevent you from knowing this life-changing fact that will make their field obsolete. Usually there's only one or two favorable studies that are even discussed, and the results are impossible to reproduce by others. You guys have seen this. You've all experienced it, or you've read it, or where you see something like, oh, taking this particular dietary supplement will cure diseases that no one else can cure. Um, the one reason you've not heard this before is because doctors and pharmacists don't want you to know. In fact, bonus points if they throw out the word big pharma and make the claim that, doctors and pharmacists only get paid when you're sick. So their job is to keep you sick. And what you'll find is that it might even cite a study that sounds legitimate. It might even be from a website that's similar to a legitimate website, or it may be from a website that is legitimate, but it uses an article that's unrelated to the claims. For example, a claim that chia seeds would help cure cancer was supported by a National Institute of Health article that was cited because it talked about cancer, just never mentioned chia seeds. So some of these things you need to keep in mind when you are looking into pseudoscience. So here are some examples of pseudoscience. Sometimes the claims can be harmless, like aliens created crop circles to communicate with us. Well, there's no way to prove that. And there's really no way to experiment with it. And it doesn't happen in a way that we can predict so that it can be studied scientifically. You might also find claims that aliens built ancient structures because obviously there's no way humans could have done so at that time period. I always kind of find that claim a little bit racist because it's based on the idea that ancient Mayans and Aztecs and Egyptians couldn't construct such structures, like they're not intelligent enough, even though we have studies that show us otherwise, show us how they actually did this. Um, and truthfully, the reason we know that this is all pseudoscience is because those claims persist, even though we have those studies to the contrary. Pseudoscience might also include claims that your destiny is controlled by the alignment of the stars when you were born. These are all things that you really can't verify. Claims of a faked moon landing. I absolutely love this one. It is an absolute conspiracy theory. And then, of course, you have things like the healing power of crystals. These are things that we can't test this. We can't prove this. And the thing is, it's not that we really even can't test it. It's that no legitimate scientific studies have indicated this. Sometimes, however, pseudoscientific claims can actually be pretty dangerous. For instance, pertussis, measles, and other infectious diseases are making a resurgence, and this is due to false claims that certain vaccinations cause autism. I'm actually going to address this again in a later video. I personally have an autistic child, and I can tell you that no vaccine caused them to be who they are. One study that is always cited that indicated some type of connection was orchestrated by a group who paid the doctor to falsify his data. He actually lost his medical license, but sadly, a lot of children have gone unvaccinated because of this. And we have some of these very serious childhood illnesses that are making a resurgence. And that's actually what you can see in this, in these two graphs, is that when we had the vaccine initially, cases dropped. And, 2010, we actually were seeing cases at rates almost the same as prior to where we had a vaccine. So just something to keep in mind. We saw the same issues with COVID-19. You know the claims that I'm talking about, right? The suggestions that directing a hairdryer at the back of your throat. Personally had a relative say that one. Or consuming disinfectant would protect you from this virus. Those claims are dangerous and they're irresponsible. And that's the type of pseudoscience that we really need to worry about most. By its very nature, pseudoscience claims are presented as secretive or forbidden knowledge, something that those with power and authority don't want you to know. So, in summary, remember that the nature of science is to work with others, to share information, update information as we learn more. Science must be repeatable and observable. Science is systematic and organized. And this is how we're going to learn about our world. You've been doing it since you were babies. You are a scientist. Thanks for watching, and I'll see you next time on The Sound of Science.